Now, before we jump into coding, we need to talk about inversion of control and dependency injection. If you are familiar with this, by all means, skip this lesson and go to the next one where we start actually creating the APIs. But if you need a refresher, you're welcome to watch this. So, the dependency injection provides an object or a service to a dependent object at the runtime. And that means that the dependency is created outside of the class that uses the dependency. Unlike concrete implementation, the dependency injection pattern uses an object, which is the container, to initialize objects and provide the required dependencies to the object. We've seen it before when we registered services with the container, and the container is responsible for providing an instance of it to the class that needs that instance. It manages the lifetime of the dependency. Imagine a class that uses different services. For example, what if we wanted to send an email using different services? In a concrete implementation, we would create a class and place methods for each of the email service that we need. Then we would pass the class into the constructor, create an object from it, and have access to all the methods. So now the class that uses the dependency uses the dependency directly as the required object is passed into the constructor. That is called tightly coupled code, and as you can imagine, we want a loosely coupled code instead. And in .NET Core, it is easy to do so as the whole framework is designed with dependency injection in mind. So how do we decouple the code in .NET Core? Well, that's where the inversion of control pattern comes to play. It delegates the function of selecting a concrete implementation type for the controller's dependencies to an external component. Alright, that's a mouthful. Okay, normally the flow of the logic inside the program is determined by how the objects are bound to each other, typically by how the classes are being passed into other classes via their constructors. With inversion of control, the flow depends on abstractions, and the implementation is done during program's execution. And this inversion can be achieved by the dependency injection. I know this is just a theory, and as such, it's much easier to understand it when we put it into code. So to give you at least a quick heads up, we will be using interfaces quite heavily from this point on. Basically, we will create an interface for each of our classes. That means we will specify an interface for each of the API calls. We will then implement the interface by creating a class that will use the DB context to retrieve the data and later to perform all the CRUD operations. And finally, we will inject that interface into a controller from which we will call the methods in the implementation class and provide the necessary data such as IDs and so forth for each of the API calls. So we will have 3 pieces in place for each of the classes. Well, 4 pieces if we count the classes themselves. These are the models we already created. So the interface with necessary methods and implementation class that implements those methods and controller that calls those methods and has the interface injected into its constructor. This way, we will decouple the service, which is the interface, the implementation of the service, and the actual use of the service in the controller. So all these components create one service, and we can then inject it into the services in the configuration services method in startup. Still confused? Well, let's just start, and I'm sure you'll pick it up quickly.